Welcome to tutorial where we take a look at the first question on our Physics 1 Module 1 quiz, which has to do with constant acceleration. Let's preview the question really quick. All right, sharing my screen, we can take a look at what the prompt is. And so there's a video for the movie A League of Their Own, in which the characters are trying to catch a moving train rather. All right, well, we're going to track two objects, and it says try and find out the following. So we would want to try and find the time, position, and velocity of each object when they arrive at the same place. And some other conditions here too. One says that they should have separate starting initial conditions, initial position and starting velocity. And one of them should accelerate. Great, well, here we go. I use my document camera to try and take a look at this example. We'll lighten it up a little bit. Great. Okay, so well, I'm not really great at drawing trains, so here's a vehicle. We're going to catch a car instead. And if these two locations sort of represent where they're starting from, oh, but we said that they should have different starting positions. So I'm actually going to take our person and move them back. So let's go back. And so they start at a different position. Okay, great. And so let's assume when the clock starts that this car is already moving. And this person's at rest, and they're going to have to accelerate to catch up to them. So, well, a moving car is going to be hard to catch. So let's think about these initial conditions here. Let's assume that the car starts off with a velocity of 5 meters per second. See how orange is showing up? Not bad. And then we'll assume that our person starts off at 0 meters and 0 meters per second, but our clock has started, the gun has sounded, and they are accelerating at 2 meters per second. And of course, we've given the car a head start here, so we should also include where the car's location is. So let's assume that they start with a head start of 10 meters. Now we can write an equation of motion for each object. And to me, that makes sense that we break it up into two. So we have our, let's just call them our sprinter. And then we have our car. And we can list the variables that we're going to need to deal with this. We usually use X for motion that's horizontal, and a 0 for the position when they are starting out. And then X would be whatever the final location is going to be. And then initial velocity, and then final velocity, and then acceleration and time. And so these are all the inputs that are going to give us an equation that's going to predict where the sprinter is at any given time. Okay, and that takes care of the car, or the sprinter rather. Let's do the car. Same thing, x0, x equals v0 equals v equals acceleration equals and time equals. All right, well, let's put in the things that we have already established for each object. So the sprinter is going to start at our origin, so that's 0 meters. And we don't know where the sprinter is going to catch the car, so we'll leave that blank. And they have 0 meters per second for something to start with. And we don't know how fast it's going to be going when it catches up with the car, but we do know the acceleration is 2.0 meters per second. And we don't know how much time it's going to take. So it seems like there are a lot of things that we don't know. Okay, and the same thing for the car. We'll go kind of quickly here. So the initial is 10 meters, and We don't know this. We know the initial speed is 5 meters per second, and the final speed is also going to be 5 meters per second, and the acceleration is 0. And the time, we don't know how much time it's going to take to catch them. So our equation of motion, this is kind of, you saw several different kinematic equations in this first module, but this is the special one. It's called the equation of motion, because it predicts where something's going to be for any value of time. So just like algebra, this is a function, and the function is going to tell us what x is, and it's going to be based on this variable called t. And then we can write in all the things that are going to impact where our object's going to be at any given time. Okay, well, there we have it. These numbers that occur up here are called parameters, and then the variable will allow it to run for any value of time. So now we can take this and then let's use a subscript to indicate which object we're talking about. So XS for sprinter, and the initial position is 0, and the initial velocity is 0, but there's acceleration. So that's going to be equal to 1/2 of 2 times t squared. And then for our car, let's go XB, that. And now it does have an initial position. So 10 plus our initial velocity, which is 5. And then there's no acceleration. Okay. Well, the question is, find out when the sprinter catches the car, or find t so that the the sprinter's position, get it out, Joe, is equal to the car's position at that time t. And so that really means that we can set these two equal to each other. So 1/2 of 2 is just 1, of course, so it's going to be t squared, and that's going to be equal to 10 plus 5t. Great. So I need to do some cleanup here. It's pretty clear that we are on a bus to quadratic formula town. And so in order to apply the quadratic formula, I need to get everything on the same side of the equation. Okay. And what's next? Well, like you think back to algebra, it's like, there we to factor this, or not really. It's probably going to be a decimal. Yeah, so quadratic formula. Now you could go ahead and Google and get an equation for the quadratic formula and how to solve it. But when you do that, you'll probably see that there are a number of online solvers. And so is it legit to use an online solver? Of course it is. It's 21st century. Use the tools in front of you. So quadratic formula, use it online, get t, and then you can substitute back into these equations to find out where they're at the same place and how long it takes to get there. So just a little quiz starter to build your confidence, and good luck with it.